Hello, everybody. I am Emily. I'm going to talk to you guys about some super cool legal data. It's not going to be anything like swag being given out, but hopefully you'll still like it. So a little bit about me and why I decided to become a data scientist. At the moment, I'm a data scientist with a company called LegalServer. It's a legal aid software company based out of Chicago. Oops. Oh, my joke was ruined. Previously, I was a business and operations analyst at an e-commerce company. I studied international relations and economics, and I'm really interested in using data to solve really big problems that people haven't really tried to solve so far. And a little bit about why the law. So you guys already saw it, unfortunately, but so I watched a lot of Law and Order when I was a kid, and I got really interested in the law because of this. Didn't really want to be a lawyer, judge, anything like that. I just think it's a really fascinating topic, and wanted to be able to figure out how to apply other sorts of means to the law. So let's look at some law and government data from a data science perspective. So when I started to do the project that I'm about to talk to you guys about, I wanted to really think big about this and think about how when I was a kid, I was about 13, I think, at the time when this happened, and I didn't know what the Supreme Court was. All I knew was that we had this election and that somebody won the popular vote but lost the election, and then it went to this Supreme Court thing, and then they decided, and it was just 9 people who decided basically that this wasn't going to go past them and we weren't going to have a recount. So this is a big deal, and I think that the major problem here is that a lot of people don't really understand the Supreme Court. So on top of this, what I discovered was that basically over 50% of cases have happened since 1940. And that's a lot of cases. If you think about that, we have 23,000 cases total. So even if you decided that you were interested in the Supreme Court, there's just no way that you could keep up with it at this point. And then on top of that even, there's been over 36 million words written in the court since 1790. That is a lot of words. So I think the problem is pretty clear here. And that basically that the average American cannot understand the impact of the Supreme Court on basically everything that happens in our country. The Supreme Court has some kind of sway in it. So the solution that I came up with was to do topic modeling on all of the cases in the entire court history. So we're going to take a look at some natural language processing applied to this topic. And I want to take a quick poll. How many people here have done natural language processing before? Okay, so not that many. So we'll get a little bit into details then. Okay, so what you start with natural language processing is we have a data frame of all of the cases. So this would be the case with any kind of natural language processing. So what is our next step? You have all of these words. What are you going to do with them? So we're going to do some text pre-processing, which I'm not going to get into a lot in this presentation because it's super boring to look at. But all it basically is you remove really common words from the data set. So then what's the next step after that? So now we're going to do some vectorization, which in the case of this project, I did term frequency, document inverse frequency, and I'll show you a little bit about that now. So TF-IDF for short, and you should definitely know this kind of vectorization, it's very popular. So what you're going to end up seeing is that super common words like maybe, let's just say the, actually, not word, but so super common words are going to get down-weighted throughout the corpus, and then really uncommon words are going to get up-weighted. So now that we have all of our words vectorized, and so that means that they are basically numbers in a data frame. What is the next process? What is the next step in the process after that? So in this particular case, we're going to use non-negative matrix factorization to do topic modeling. This is where, with deep learning, what you guys have been learning this weekend and various other things, you can do a lot of different algorithms at this point, but the one that I chose for this project is non-negative matrix factorization. So non-negative matrix factorization is an unsupervised learning algorithm that takes documents in the entire space, so every single one of these, yeah, cool. Oops, what? Well, I didn't know that did magic, but, okay, so, well, I'm getting this back up. So, it is a unsupervised learning algorithm. You guys know what unsupervised learning is, right? Okay. So we won't use that laser pointer anymore. So each one of these documents is a Supreme Court case. And then it is going to take the, and I'll show you guys a little bit of the linear algebra in the next slide. So it's going to take these, the steps in the linear algebra process and go and get latent features and then put them into the topic space. So really, what does that mean? So we're looking at the hidden layer and then the exposed layer. So for those of you who do understand natural language processing, the exposed layer is going to be our sparse matrix with the all the TF-IDF features in it. So what is going on in the background here is that you have two matrices that are doing matrix factorization, and they're going to continue to do this process of multiplication until it converges on the local minimum, which is a gradient descent process. So does that make sense to everybody? Okay, cool. Okay, so just want to go quickly over the kind of the background of what we did here. So we've reached the end of the natural language processing part. I'm going to show you guys the results of this in the next slide, but we had over 23,000 cases. And we ended up with about 5,000 unique words with TF-IDF, and then we grouped into 20 topics with NMF. So what I really thought when I decided to do this project was that a really important thing was going to be communication, that this is a topic that not a lot of people have touched unless they're doing it in poli-sci, PhDs, and things like that. And I thought that if this was going to be really impactful, I needed to present it in a way that people could actually touch themselves and look at. So I'm going to look at it. You're going to have to bear with me with the way that this is going to go. But so okay. So this is the visualization that I made. I'm not sure if I can maximum this, but okay. So this is with D3.js. If you guys have, some of you may be developers now, but D3 is an awesome library for doing data visualization, and it's super simple to use once you get to learn it. And it's really easy to plug your stuff into other people's previously made visualizations. You can actually use this if you want. I presented this on GitHub, and I'll tell you what my GitHub is at the end of this. So what I really wanted to do here is make a visualization that you could actually, interact with. So what you can do when you look at this is look at, through the years, kind of how these topic spaces have sort of started to build up. So this is all the results of non-negative matrix factorization put into a graph, which is, I think, super interesting. And you can see, the results of this algorithm, how kind of accurate it's gone and done these things, which is really, I think, impressive considering that it's an unsupervised learning algorithm. And so, you can see up through here that things like civil rights have become really a big topic. And one of the most interesting things that I think about this particular topic is, going back to how many cases have happened since 1940, that the most cases in history were in 1967, which is not even, that's not even data science. It's just sort of looking at the facts, without even doing any data manipulation, which I think is really interesting. So this is available on my website and also on Blocks if you want to look at it a little bit more and get to know some things. You can also go and look at these cases, some of the examples that I've pasted. So one of the really cool things that resulted in this was once I released this online, I got a lot of interest, and I thought that it really went to show how much people really want to see more work done in this space. And so this is the reason why I think Laura wanted me to talk to you guys today, is especially what I'm doing for work now. So basically, the project that I'm working on is supposed to have a really big impact, and it's kind of in the late stage development at the moment. So basically what we're working on is connecting the clients in need in legal aid with the appropriate pro bono lawyer for their case. And I don't know, does everybody know what legal aid is? Okay, so this is a really important thing because a lot of these clients can't even afford a lawyer at all, but they have really big problems. So they need to be able to get connected with somebody as quickly as possible. Sometimes they've been kicked out of their apartment and they're homeless at this point. So the impact that this is having is that currently only 15% of potential clients get the initial call that's even having somebody from the law firm connect with them at all. And what this is going to do is 100% of potential clients are going to be in the system, and lawyers will be able to find them or possibly get an email when somebody with the appropriate case has come up. So currently they're doing manual client intake, which is just on the phone most of the time, and what they're going to be able to do is save at least 2,000 attorney hours a year, which is $100,000. That's a lot of money. And then right now they're spending a lot of grant money on administrative tasks, such as manual client intake and things like that. And they're going to be able to spend a lot more money on actively helping clients, which I think is really important. So kind of to wrap this up, I want to talk to you guys a little bit about what you can do. And I think that pretty much anybody, as long as you have some kind of understanding of natural language processing, which I have written a blog about this, so you guys can totally go and look at that and get some indication of how to start on that. So you can go to my website is emilyamillion.me and look for more civic data projects, and data.gov and Free Law Project, which is actually based out here, and they're putting a lot of court data up online. And then usa.gov/statistics, and then there's always so many more. So that's it. So anybody have any questions?
How long did all of that take?
Well, I did this as a final project for an intensive program, so it took me probably 3 weeks, like working night and day. But I was also more of a beginner in data science when I did it, so I think if you have natural language processing skills already, then it would probably take a lot less time. I also collected all of my data, which took like a week of that because I was figuring out how to use web scrapers at the time. Any other questions?
Before you said like you were kind of new at data science, where were you, like what was your experience before?
Well, I was a business and operations analyst, so I was doing programming in Excel. I did VBA, but it's an extremely different, kind of programming than Python. So I got into the program that I got into because of that experience, and then I basically was learning Python as I was doing the program. And I can talk to you a little bit more about that too after, if you'd like to ask a little bit more about it. Any other questions? No? Okay. Oh.
I know there's been, what I was familiar with before was expert systems for law.
Mm-hmm.
And you see machine learning being used for, I guess for judging the probable outcome of a case. Do you know of any work that's being done in that field?
Yeah, that's a really excellent question. I think so. I think actually, that's also of interest to bigger law firms that aren't, because the legal aid system is almost entirely on grants. So the bigger law firms are not prioritizing the work that I'm doing because they do everything hourly. So it's not really in their best interest to do what I'm doing. So they're exploring other kinds of machine learning routes with the law. So I think I heard of one, but I can't remember the name of it right now. But I'm pretty sure I read an article recently about that. I'll connect with you.
Sure.
Yeah.
So we're talking about future applications.
Mm-hmm.
I was reading somewhere where somebody was kind of musing about the possibility of having the sentiment analysis
Mm-hmm.
cameras watching the faces of all the jurors in the jury trial and scoring, maybe even a continuous feedback way.
Okay. That sounds super creepy, but yeah.
Something like
Yeah,
that.
no, I've never heard that before, but yeah, I mean, I think with all things machine learning and AI, some of the stuff is really invasive, and I wouldn't personally love to know if I was on a jury that somebody was watching my face the whole time. But that could be the future. I mean, that could be the case. I know of a startup that is working on jury selection, and they're using social media data to help connect those lawyers with the right jury people, which I don't think it's as invasive as some other sorts of things. I don't think that they're, looking at their Alexa streams or anything. But yeah, that could be really interesting. Yeah.
And another question. So what conclusions did you draw from that changing pattern of cases by the Supreme Court?
Yeah, absolutely. So the kind of conclusions that I was able to draw as sort of a layperson looking at this, as somebody who studied poli-sci but has never, gone to law school. Basically, when I presented the most cases ever happening in 1967, I think that's a really interesting point, because what my kind of theory is about the Supreme Court is that most of the time, the cases that they see, because they're always presented with these cases, like they're not going to go out and get a case or anything like that. It always comes up to them. So the cases that come up to them end up being really big social impact cases. And I think that using this kind of machine learning and various like AI kind of applications to the Supreme Court, you can actually get a real proof to that theory. So not only are there, the most cases in 1967, but especially if you look at the reason why I showed the this one, yeah, civil rights, is because you can just see how that topic builds over time. That it's of some interest earlier, and it's clearly more impactful than some of the other topics that are going on. But it becomes so much more prevalent through times of really big uncertainty in our country. And I bet, without getting too political at the moment, I think that in 2017 we're going to see a lot more civil rights cases again. So that's kind of the overall, like, overarching kind of conclusion that I had come up with. But it's, this is a really interesting graphic, I think, that if you just sit and play with, and also something I didn't show you guys is you can zoom in on certain time periods too. So if you want to, so if you want to sort of like, look between like 1930 and So this is like, this is a really interesting thing. I like to, when I'm doing longer talks about this subject, sort of play with it on the screen, but it is really so much better for you to sit on your computer and play around with it.
Did you have to do any work on sort of standardizing the language across time? The way that they write and speak in 1790 is not the way they write and speak in 1990. I saw you had some clustered topic words there.
Yeah, that's a really interesting question. Yeah, I actually did not. No, I was planning on it, and then it turned out that I didn't actually have to because of the results. Basically, I was advised by my instructors at the time that it actually wasn't necessary. I had done a project similar to this previously for trying to determine what a Supreme Court justice would be like once they got on the court. And so I was clustering with k-means on their, basically like their languaging. And it actually didn't end up being very, it's surprising, but their languaging is actually very similar across all kind of areas of the court. So I think that it doesn't end up having as big of an impact as you think it's going to have. Maybe for like
the industry. I mean, the
exactly.
section, right?
Yeah.
This might be a little more consistent than say
exactly. Yeah, and I think those kinds of things would be better if you admittedly knew more about the Supreme Court than I do. I don't want to unintentionally introduce any bias into this particular topic. I mostly just wanted to do a toy project. But if you were to do, some PhD research or something along those lines, some kind of academic research, that would probably be a really interesting thing to explore, because there could be more about that than I even know. But yeah, and you can also, so currently where I'm at is that I have a GitHub repo that you can fork and play around with. Has the web scraping code in there, so you can go on and get the data yourself. What I'm working on at the moment is getting a zip file of all the Supreme Court data and putting it up on my website, so that should be this week. So if anybody's interested in actually doing a project like this themselves, and they don't feel like running the web scraping code for 6 hours, then please, by all means, I put all this stuff up because I want more people to do these kinds of projects. So let me just get this up here. So it's Supreme Court topics over time, one word, because I don't know grammar sometimes. Yeah, so you can look at this, and the all of the D3 code is in here. So if that interests you more than doing the actual data science of the project. Cool. Anything else?
So one question is, what do you think of the topics you said? It was increased relevance on the
Can you speak up just a little bit?
So you said you used the algorithm to automatically break apart the Supreme Court
Yeah.
topics.
Mhm.
Did you have to do a normalization of that manually to break up the topic and sort of graph?
That's a really good question. So I used non-negative matrix factorization from sklearn. So there is a really powerful NMF from already in the API of sklearn. So they can, if I understand your question correctly, and if not, please talk to me more about it after. You can introduce L1 or L2 regularization. So that is what I did. So, if that, I don't know if that answers your question.
No, I was just wondering, because you have topics, so when you looked on the Supreme, if you go back to the graphic,
Mm-hmm.
I think he's talking about the way that it was clustered, those topics.
So if you look at chronologically, and you hover over that, it shows you topics alerts. So do you have to kind of extrapolate through activity nonviolent?
Oh, I see what you mean. Like,
Those topic alerts?
do you mean like naming of the topic, or?
Yeah, did you have to say these topic words are part of this criminal activity?
Yeah. So that is a really excellent question. So I actually am extremely lucky in that I know my sister is a constitutional lawyer, so she helped me name some of the topics, and then also one of my instructors from Menace has a PhD in poli-sci. So both of them together kind of helped me collaborate. Some of them are really obvious, so I did those basically myself, but the topic words, just to kind of clarify if anybody is not understanding how these got here, is that when you do non-negative matrix factorization, which you can see this more in the repo, you can go through, and I have one entire notebook is dedicated to kind of walking through this. That you do kind of an arg sort, which is the matrix sort. So you do that so that you get the most important words for each category sifted up to the top. So, a lot of these topics definitely have overlaps of words, but that the most important ones for each topic get sorted to the top just based on, math at that point. So this is one of the ones that I found pretty obvious. So especially 14th refers to the 14th Amendment. So definitely look at that more. If you have any questions, like when you're looking at this or looking at the repo, please reach out to me. I want to make sure that it's clear to anybody who looks at it. And I get questions all the time about this. So, any other questions? Cool. So if anything comes up, just come up to me afterwards.